that we know a little bit more about identifying tables that represent linear functions, let's take a look back at our table. Let's check out the x values. Well, first we want to go from 1 to 2. To do that, we could add 1. Now what about going from 2 to 3? Well, there we could add 1. And how about 3 to 4? Again, we could add 1. Each time to get the new x value, we simply need to add 1 to the previous x value. So we can see that x has a constant rate of change. But what about the y values? Well, let's take a look. Here, y needs to go from 12 to 7. Well, to do that, we could subtract 5. Now what about going from 7 to 4? There we could subtract 3. And from 4 to 3, we could subtract 1. Now take a look at that. As our x values are increasing, our y values are decreasing. Now that's okay. We could have a linear function with those characteristics. But we need to make sure that x and y each have a constant amount of change. We already know that x does. But y looks like it changes a different amount each time. Here we subtract 5 to get the new y value. Here we subtract 3, and here we subtract 1. We're subtracting a different amount each time. That means that those y values do not have a constant rate of change. And since those y values do not have a constant rate of change, we know the answer to this question. No, this table does not represent a linear function. If we plot these points and connect them, we will not get a straight line.